welcome to my YouTube channel. In this video, we'll learn about transmission gates. Transmission gates are used for building logic circuitry such as D-latch or D flip-flop. This is an example of internal circuitry of a D flip-flop. Gates TG1, TG2, TG3 and TG4 are called transmission gates. Transmission gate acts like a switch. If transmission gate is on, then the input passes through the gate and appears at the output. If transmission gate is off, then input is blocked from the output. Transmission gate is comprised of a PMOS transistor and a NMOS transistor. The control gates or the gate terminals of the transistors are biased in a complementary manner so that both transistors turn on or off at the same time. When transmission gate is used to build D flip-flop or a latch, the control signal applied to the gates will be the clock signal. When VG is 0, NMOS is turned off. Inverse of VG is applied to PMOS and PMOS is also turned off since 1 is applied to the gate terminal. The transmission gate acts like an open circuit. When VG is 1, NMOS is turned on. PMOS is also turned on since inverse of VG, which is 0, is applied to the gate terminal. In this condition, input appears at the output. The source and the drain terminal are decided by the flow of majority carriers. In NMOS, electrons being the majority carrier will flow from lowest potential to the highest potential. Therefore, drain terminal is the terminal that is at a higher voltage than source. For PMOS, since holes are the majority carriers, source terminal is the terminal that is at a higher voltage than drain. Let us see how NMOS operates when input is 0 and 1. Consider that VG is set to VDD and VDD is greater than VTH, which is a threshold voltage. If input VD, that is the drain voltage, is set to VDD, which is logic 1, Vs will start charging to VDD and NMOS will be on as long as Vs is less than VDD minus VTH, because for NMOS, VGS should be greater than or equal to the threshold voltage. When Vg is equal to VDD and Vs is charging to VDD, NMOS will be on only up till Vs is less than VDD minus VTH. When Vs is equal to VDD minus VTH, VGS will be equal to VDD minus VTH. So, VGS is equal to VTH. For NMOS to be on, VGS should be greater than or equal to VTH. When Vs is greater than VDD minus VTH, VGS will be less than VTH and NMOS will be turned off. That is why NMOS is not good at passing 1. We saw that NMOS is turned off before Vs is charged to VDD. When input is discharging to 0, NMOS is always on since VGS is always greater than VTH. NMOS is not good at passing 1, but NMOS is good at passing 0. For PMOS to be on, VGS should be less than the threshold voltage. When VG is set to 0 and Vs is set to VDD, which is logic 1, VGS will be less than the threshold voltage till VD is charged to VDD. That is why PMOS is good at passing 1. When logic 0 is given as input to PMOS, Vs, which is now the output terminal, will discharge only up till VGS is less than the threshold voltage. When VGS is equal to minus zero point 0.2 volt, in this case, Vs will stop discharging. This is why PMOS is not good at passing 0 since Vs is not completely discharged to 0. We saw that NMOS is not good at passing 1, but NMOS is good at passing 0. Similarly, PMOS is not good at passing 0, but PMOS is good at passing 1. Thus, PMOS and NMOS are used together in transmission gates to overcome these shortcomings. Understanding the working of transmission gates will be helpful while learning the setup and hold time requirement of flip flops. Make sure to subscribe for more content. See you in the next video.